Okay, before I forget, I want to remind you that as I look at the lesson plans I made for you two this week, I noticed that I put, for the math, I put 130, 131, 132, and 133. 132 is actually a test, which we're not really doing. In fact, this lesson that you're doing today, I'm going to use as a test. Although it doesn't really make any difference in the grades. I grade everything the same. But I won't be helping you as much as I normally do. So when you see the 132 on Wednesday, change that to 133. And so we'll do 134 on Thursday. All right? Okay. Today's lesson is a review on geometry. And so we're going to use it as a review. I'll go over a couple things with you, and then I'm going to leave you on your own with this lesson. Remember with number 1 and 2, change my pen. Hold on, there we go. You are marking the measures that are acute and the angles that are obtuse. Let's just review real quick. Remember, a 90-degree angle is called a right angle. Anything smaller than 90 degrees, in other words, let's say 1 to 89 degrees, would be called acute. And we remember that thinking they're cute, they're little, they're smaller than 90 degrees. 91 degrees to 179 degrees would be considered obtuse. They're the big ones. And then if you're at 180 degrees, you have a straight angle, which is really just a straight line. And just for review's sake, 360 degrees would be the entire circle. Okay? So in these you're marking the measures that are acute and then the measures that are obtuse. So remember that as you do it. Number 3, you're just writing the area for the different shapes. If you forget them, you can look back in old lessons. And don't forget, there is the tan section in the back of your book. That's like a handbook, and that may have some of those formulas back there if you get stuck. Number 4, you're doing the circumference and the area of a circle. Number 5, you're measuring the angles. And don't forget, you're probably better off if you take your protractor or your ruler and extend these lines out. Just make sure you're doing them nice and straight. And that way the lines will run right through your protractor and you can see the measurement easier. Number 6, you're naming the different polygons. We'll just do A just so you know what they're looking for. A 3-sided polygon, you know what that is? It is a triangle. Pretty easy, right? The tricky ones will be the 7-side and the 6-side. They're probably the trickiest ones. If you get stuck, you can always look in the back. I don't mind if you look in the back. All right, let's look at the other page. So number 7, you're drawing 2 circles. Remember, use your compass. Your compass, you will measure the radius. So this one is in diameter, so you're going to have to half that in order to set your compass at the right spot. Don't forget, right here, that's not 4 6, that's 4 to the 6th power. So you're multiplying 4 6 times. Might be easier if you take that one and that one. Oops, I need one more. And these two, and then multiply those together. That is a pretty big number. Don't mess up in your multiplication. Don't forget on I, you put the 15 over 1, and then you change this to multiplication and you flip it. I wanted to do M with you, and then that's about it. Oh, I wanted to go over that right there. So M is really no different than K. So let's look at K. K is pretty easy. Let me clean up my page and erase all this. So we have 7/8, and that equals something over 64. So remember what we did? We looked at that 8 and we asked, what did I multiply that 8 by to get 64? You multiplied it by 8. Therefore, you multiply the top one by 8. Remember that? That's easy. So we do the same thing with m. It just looks trickier because it's a fraction on top, which is really strange, and I don't know why they put these in here randomly, because I don't remember them ever really showing you how to do these. But here we go. So same thing. We're going to figure out what are we going to multiply 8 by to get 3/4. And the first thing you notice is that the 4 is smaller than the 8. And don't let that trip you up. All they've done is they've reduced a fraction. So let's think about it. Let's try multiplying 1/8 by 2. And when you multiply 1/8 by 2, what do you get? You get 1/4, which we're on the right track, because this one has a 4 as a denominator, and so does this one. But we need 3/4, not 1/4. So I'm wondering if 2 over 1 made 1/4. I wonder if 4 over 1 would make 2/4, which would be 1/2. And sure enough, it does. Look at that. It's 4/8. So then let's do a little pattern here, and now let's use the 6. What do we get when we multiply by the 6? We get 6/8. Does that reduce to 3/4? It sure does. So 6/8 is our real answer, but they've reduced it to 3/4. So we have multiplied 1/8 times 6 to get to 3/4. So you're going to multiply the 5 by 6, and that will give you your denominator. All right, the only other thing I want to go over is this 5.5% right here in this problem, because what happens is sometimes you guys forget to move the decimal if you're changing a fraction to a decimal first. So let's just review. 1/5, what is that as a decimal or a percent? 20%. So 2/5 is 40%. 3/5 would be 60%. And 4/5 would be 80%. Remember, we memorized those. All right, so 1/5 is 20%. So I'm changing the 5th to 0.2, but this is still a percent. And I still have to change this to a decimal before I multiply it by the $2,500. So you need to move the decimal over twice and then put the decimal here. Now you could do two things. You could multiply this by 2,500. Lots and lots of zeros. Or you could put these two zeros on hold, put this 0 on hold. You could do 25 times 52. Don't even think about the decimals right now. Multiply that all out, and whatever your answer is, put 2 zeros at the end, a 0 at the beginning, and then put your decimal in. You'll get the same thing. And I think it alleviates the chance for errors, as opposed to, I think I might do it with you. All right, so let's do that. We'll do it both ways. I'm going to do it up top here where I have room. So I'm going to take 2,500 times 0.052. Okay, and I hope I even have enough room. I probably should put it closer. All right, so I'm going to write small so I can fit it. So that's a 0, 0, 10, 5. You can just watch me if you want. 5, 2, and 10, 12. Right? All right. And then this one I don't even have to do because I'm just going to get all zeros. All right, so let's add it up. Move it over 3 places, and I get 130. All right, now let's try it without the zeros. So now I'm going to get rid of these two, and I'm going to get rid of this one. And I'm just going to do 25 times 52. What I do? Oh, I don't know what I'm doing here. Let me get rid of this. So it was 10, 5, 5, 2, whoops, 12. There we go. Okay, now put in these 2 zeros that you took out, and we probably won't even need this one, but put that one over there. And then we have 3 places after the decimal. 1, 2, 3. And guess what you got? 130, which is what you got before. So you get the same thing. And doing this right here is a lot easier than all of this. A lot of zeros. A lot of chances to mess up your lines because you got so much going on. So that's why I like to do it that way. All right. I think that's all I want to go over. These down here are pretty cut and dry. The areas, they don't have to make any conversion of the measurements first, which is nice. So just take your time on it. Sure, get some help if you need it from somebody. Look in the back, do whatever. And we'll see how you do more on your own on this lesson and less of me. All right. I will talk to you guys later.